back for 4.5. Hopefully the quiz went well for most people on Friday. I see we're maybe losing a little bit of interest in the activities. I can't stress enough how much, if you don't put a little bit of effort in now while you're just sitting at home, how much worse it's going to be when you take a stats course in university. You can basically, by taking this course, you can basically get through a lot of the meat that's in a stats course in university. So having learned it ahead of time will make this, you know, stats an easier course for you in university instead of a more difficult one. Okay, the last lesson, which is really just one small step to what the previous lessons were. We're still dealing with normal distribution. We're still dealing with z-scores. But everything we've done so far has either pertained to things being less than, or things being greater than, or things being between two values. What happens if we get to a situation where we want it to be exactly equal to a number, or greater than or equal to, or less than or equal to? Well, these symbols we haven't yet seen in a normal distribution. We've only seen these two. So basically we're taking what could be a discrete point. What is the probability that x is exactly 5, equal to 5, greater than or equal to 5, less than or equal to 5, and changing it into something where we can use a standard normal z-score table. Okay, so we want to be able to change it so that we can use that normal distribution, we can use the table. And remember, the chart in our book gives us always less than a specific value. Okay, so we're really looking to get it into this eventually from any of these. We already know this one, we do 1 minus greater than in order to get less than, but what do we do in all of these situations? Okay, well what we're going to do is we're going to take the value, the x value they gave us, and add or subtract 0.5. That's the actual correction. So it's called a continuity correction because you're changing it from discrete data to continuous. That's where the word continuity comes from. And to do that, we're going to add or subtract 0.5. So that's sort of somewhere you say, okay, this is the idea. How are we going to add or subtract 0.5? I'm going to get to that, but that's the idea. Add or subtract 0.5. And the way that we're identifying in which direction, whether we add or subtract, you can't do both, unless it's an equal to, is to look at the wording they use. So I'm saying here you have to have a firm understanding of these phrases. What does it mean when it says there are at least so-and-so number of things? There are at most. There are more than, there are less than, there are this or more, this or less. Because that will determine, understanding this language will determine what symbol you use. Understanding what symbol you use will help you determine what continuity correction you need to make. Okay, so it comes from the language first. You have to take the English words and convert them into a math symbol. Then you'll take the math symbol, add or subtract 0.5, and then we'll do a normal z-score question. Okay, so this is not necessarily really in your note exactly like that. Your note should look like this if you've printed it off. It'll be sort of in the exact same manner. I'm going to go through the examples with you so that you get an explanation. I don't know if the videos are worth doing. They are somewhat time consuming for me to film, to upload. So if they're not useful and people aren't watching them, I don't need to spend my time doing them. But if you do find them useful, maybe send me an email and let me know. I'm just trying to figure out, you know, sometimes you get 10 views and there's 50 people in the class, so if I'm getting 10 people watching them, I'm not sure they're worth doing if you think you can figure it out on your own. Okay, so the first example is just trying to write the probability statement. So it says here in example 1, we want to convert these words into a probability statement. So it starts like this: at most 5. B goes more than 5. Okay, so I use the number 5 for all of them. And basically you want to turn it into a probability statement with x's like we've done. So you have to decide, does it include the value or does it not include the value? So at most 5 would be anything up to 5 and including it. At most 5 means it can include 5. So we're basically saying this is probability that x is less than or equal to 5. That's really what that statement is saying. At most 5 means it includes 5, so it's less than or equal to 5. More than 5 Does that include 5? More than 5 does not. It's specifically saying it must be greater than 5. Okay, so you're taking all of these words, at most, more than, and converting them into the inequality symbol. Okay, less than 5, again, does not include 5. It has to be specifically less than 5. Up to 5, but not including 5. At least 5, at least means it's greater than. It does include 5, so it's greater than or equal to. Exactly 5 would be probability that x is equal to 5. Now, when we do a correction, we kind of look at this and we say, well, this is less than, this is perfect. That's the scenario where we just look it up in the back of the book. We will convert that into a z-score, look it up in the back of the book. When it's greater than, you'll remember you have to do 1 minus the probability that it's less than. Okay, and then that's done. So those two we've already looked at. The bigger cases are the other 3. What happens when you have probability that x is less than or equal to 5? How do you convert that? Probability that x is greater than or equal to 5. And the probability that x equals 5. Well, what you have to do here is do a conversion that we call a continuity correction. So if it has to be less than or equal to 5, we still must include 5. So this is approximately equivalent to, we want to change all the symbols to get rid of the equal part. Okay, so it either has to be less than or greater than, but we want to get rid of the equal to. But because this included 5, we have to include 5 over here. So we want to go 0.5 above. So this said x is less than or equal to 5. This still includes everything that is less than or equal to 5, plus 0.5 above. We have to make the correction in some way. We could have done 0.1s, we could have done 0.2s. We're going to use 0.5 so it's consistent across. So this will still include everything that this included plus a little bit more. Okay, when it's greater than or equal to 5, we again need to include the 5. So we're not going to go greater than 5.5 because that doesn't include the 5. In this case, we're going to have to do greater than 4.5. So you always have to choose, do I go above by half or do I go below by half? And it all has to do with what it's including. So if it has to include the 5 and you're going greater than, then you go down by a half. If it has to include the 5 and you're going less than, then you have to go above by a half. Now, if it has to be exactly a value, this one you're changing to a range. You're going to go both above and below. So we're going to say exactly 5 is equivalent to between 4.5 and 5.5. Okay, so this is the correction. Once you make the correction, this is the whole idea of today's note. Can you make the continuity correction? Then these just become questions like we did in 4.1 through 4.4. Okay, they're the exact same questions. The purpose of this note is to make you make the correction first. Then this one is ready to go. It's already less than. You change it to a z-score, you go. This one is greater than. You have to do 1 minus the probability it's less than, then you go. This one is between. You have to do the probability it's less than this, subtract the probability it's less than that. Okay, so these are the corrections. We're going to do a couple worked out examples to refresh your memory about normal distribution. There is an assignment coming up that you'll have Thursday and part of Friday to work on. I'll probably extend the deadline into Friday. There's no need for me to have it due at noon really because I'm not going to mark them till next week. So if I give you till midnight, that's probably fine. So you'll have 2 days to work on this assignment whenever you find time. It won't be super long. Okay, so let's get through the other examples and then from there, this kind of acts like a good review of the whole unit as well. Okay, so the second example looked like this. Manufacturer cereal finds the masses, blah, blah, blah. What proportion of these boxes is between 183.7? Okay, this one doesn't actually have a continuity correction. I'm going to be choosy which ones I choose. If you look at example 2, it says that the average is 200 grams with a standard deviation of 16.3. So in this one, I built my normal distribution and added and subtracted 3 standard deviations from either side. And I found that it landed right on the bars. So I used the 68, 95, 99.7% rule to find out that exactly 68% went in between. To find out what's more than 216.3, you use the same rule and find out 16. So that one doesn't have a correction in it. So I don't necessarily want to do it. Sure. Oh, the corrections are going to start in example 3. I want to do example 2 with you. I guess example or C was okay. Let's do, okay, never mind. It's a good example. Let's do all of example 1. Fine. Okay, so this is example 2 on here. It's because it has good questions as you go through. So this is a good example. X bar is 200 grams. Standard deviation of 16.3. Okay, so a couple of questions. How many contain between? So A says find the probability that it's between 183.7 and 216.3. I'm going to write all the questions up here and then kind of answer underneath and erase as I go. So the first one wants to be in between. The second one wants you to find the probability that it contains more than 216. More than simply means greater than 216.3. C wants, so you have to be careful because you don't know when a continuity correction is going to creep in or not. C says, how many shipments of 120 boxes would you expect to contain? So this is important that you read that part. How many of 120 are between 178 and 225? Okay, and then D says, determine the range of masses that you would expect 90% of the boxes to be in. So this is dealing with percentiles. So I talked a little bit about percentiles in the last one. Okay, so the range of boxes, 90% of masses are in. So when you start to answer these, when you look at a question like this is actually a great question because it contains a little bit of stuff from 4.2, which was the 68, 95, 99.7% rule. And then a little bit of stuff from 4.3 and a little bit from 4.4 percentiles. So this is a good review question before we even get into a continuity correction one. So if I look at just drawing the normal distribution out, so some people really like drawing them all so they can see exactly what's happening. So when you draw it, you always put the mean right in the middle. This one has a mean of 200. Okay, and then from there, again, just for review, you always have 3 standard deviations above, 3 standard deviations below. Now, in order to figure out what numbers go on these lines, you simply add a standard deviation 3 times and then subtract it 3 times. So then this number here becomes 216.3 because I added 16.3. Then this number becomes 232.6 and then 248.9, right? Yeah, 248.9. Well, you do the same thing going the other way. You'll subtract, so you get 183.7, and then you'll subtract again. So I have 183.7 minus 16.3, 167.4, and then I subtract one more time. I get 151.1. Okay, so those are all the numbers on there. Now, the idea here is, if I'm doing this first one, A, probability is between 183.7 and 216.3, you notice those are both lines. 183.7 is here, 216.3 is here. So this is 1 standard deviation on either side. So you may remember the rule that said 68% are within 1 standard deviation, 95 within 2 standard deviations, 99.7 within 3. So this answer here is simply 68%. You really don't need to show more work than there. B is similar. B wants you to find out how much is greater than 216. Well, greater than 216, we take this spot here and just go greater than. Now, if you remember, this is 13.5, this is 2.35, this is 0.15. You may have to look at your charts. You'll realize that when you add those up, 13.5, 2.35, and 0.15, that you'll get exactly 16% or greater than that value. there's no need to convert to z-scores here because they line up right on the standard deviation lines. And that's the important part. If you can use z-scores if you want, of course. If you tried to use a z-score here, you'd find the z-score between -1 and +1. You're going to get the same answer, 68%. It's a little bit more work. If you recognize that they land right on the bars, then it's easier to do it this way. Okay, now C asks you how many of 120, so this is going to become important, are between 178 and 225. So if you look for 178 and 225 here, you're going to find that they don't land on the bars. When they don't land on the bars, you must convert them to Z values. Oops, forgot the less than sign there. Okay, you must convert them to Z values. How do you convert them to Z values? You use z-scores. So if I just sort of look at this and say I can get a Z value for that by using this X, 178, minus the mean, 200, divided by the standard deviation, and I find out that this Z value is 178 minus 200, 16.3, to 2 decimal places, -1.35. So that goes there. And then this Z value can be found doing the same thing, 225 minus 200 over 16.3. So 25 divided by 16.3. And I get this one to be 1.53. Okay, so 2 calculations to find the 2 z-scores. Now you have to do the one step that said, if it lies between 2 values, you do the probability it's less than the larger value and subtract the probability it's less than -1.35. Because the idea here is if you're trying to find this in-between area, you need to find the whole less than, but then you don't care about this one, so you subtract that one out. So you find less than 1.53 minus the probability it's less than -1.35. So here you're really just looking up 2 values on the z-score table. So again, I'm assuming based on the quiz, either all of you are really good at using the z-score tables, or one of you is really good and the rest of you are good at communication. So 1.53, you look here, you have to look for 1.5, and then you go across to 0.03, and you get 0.9370. That means 93.7% of the data is less than this, which makes sense, right? That's a big, huge area under that curve. And then -1.35, you go on to the left side, -1.35 is 0.0885. Okay, when you subtract those, 0.9370 minus 0.0885, you get that in total 84.85% of the data is in between. Now this is the part I've highlighted this. How many of the 120 is that? Well, if 84.85%, then you just say, therefore, multiply these together. Multiply 120 by 84.85%. And you get 101.82. Okay, so it says, how many of the shipment boxes would you expect to contain? Well, because it's not quite 102, we're not going to go up to 102. So we'll say 101 of the 120 shipment boxes will contain between 178 grams and 225. Okay, so again, this is a pure 4.2 lesson A and B. C is a pure 4.3 lesson review. Okay, as we move on to D, this is one I haven't really worked out for you. So this is kind of a great one for me to show you because we haven't done a percentile one, so to speak, where you look in the gut. So I'm going to erase this part. It's all on your notes. Very easy for you to see what it means. But this one needs some explanation. So if you watch the explanation, it'll sort of make your life a little bit easier. Okay, so D wants us, the range of masses 90% of the boxes are in. So the idea here is, imagine you have a normal distribution. and you know 100% of the data lies under this curve. Well, you want to find where 90%, the middle 90% of the data lies somewhere. So you're trying to find what are these values right here. Okay, and how do I figure out what that means? Well, if 90% of the data is in the middle, how much does that leave left over of the 100%? We've already accounted for 90% in the middle. So to get up to a full 100% of the data, that means there's 10% left. Well, because this is in the middle, that means there must be 5% taking up that chunk, and there must be 5% taking up this chunk. Well, as a percentile, because the back of the book always tells us what's less, this is called the 5th percentile. Okay, because it says that 5% of the data is less than this point. Well, what percentile do you think this is? This has the percentile tells you what percentage of the data is less than a value. Well, from here, there's 5% above. How much is below? 90% plus 5%. 95th percentile. If 5% is above, this is considered the 95th percentile. Okay, so in order to solve these problems, what we want to do is look for the value in, remember we talked about the guts. So that's in this part of the book. Okay, and we're going to work backwards. We want to find the closest value we can to 5%. So the closest thing we can find to 0.05. We also want to find the closest thing we can find to 0.95. We want to turn this into a z-score. So we're going to work backwards now. Okay, we're going to go and look and find out what is closest to 0.05 and what's closest to 0.95. So these are all in order, right? The one that's at the end here is closest to 0, and the one that's over here is closest to 100%. So 5% is going to be way over here in the negative section, 95% is going to be somewhere in the positive section. And you kind of have to look through and find the one that's closest to 0.05. So closest to 0.05, I find 0.0495 and 0.0505. Well, those are both, so they're at z-scores of negative 1.64 and negative 1.65. They're equally far away from 0.05, so I actually have to go right in the middle of those. So negative 1.64 and negative 1.65, right in the middle of those is negative 1.645. Okay, so that's the z-score we have. To find the closest one to 0.95, I think we're going to be in the same situation because it's symmetric. So it's going to be 1.645. It's right between 1.64 and 1.65. If you add those two and divide by 2 to find the average, you'll get this value. So these are the two z-scores we would like to work with. This question, percentile questions are all about working backwards. So normally we have an x value and we're solving for z. This time we have a z value, we have an x bar, and we have a sigma, but we need to find the x values. We want to find what x value actually goes on this 5th percentile. Which one goes on the 95th? We know they're somewhere over here, but what values are they exactly? So in order to do this, we're using the same formula we used before, but backwards. Okay, so if we have a z value of negative 1.645, and we have an x bar of 200, and we have a sigma of 16.3, we can in fact solve for x. How will you do it? Using grade 9 math. Okay, you are solving an equation. To undo a division, you do the opposite, which is multiplication. Those cancel. Okay, you can then, if you want, calculate this step, 16.3 times negative 1.645. And I get, I'm just going to kind of move this around here. On this side, I get negative 26.8. I'll do it to 1 decimal place is fine. And on this side, I have x minus 200. So the last step is just to bring the 200 over to the other side. So I'll add 200 to that. And I get an x value here of 173.2. That's my first x value that pertained to this. So this specifically pertained to an x value of 173.2. I now have to do the same calculation to find this was my first z-score. To find my second z-score, I'll do in blue just to separate it. That pertains to use my second z-score to find the new x here. So this one I'm putting in same formula we use for everything. 1.645 is x minus the mean, which is again 200 over 16.3. I'm going to do the exact same thing. You can look it up on the other thing and you'll get 226.8. Okay, so this one was 226.8. So when they are asking what range of masses do 90% of the back boxes fit in, well, the range of masses is between 173.2 grams and 226.8 grams. Okay, I would highlight this example on your worksheet because you're going to get it on the assignment on Friday or Thursday. Okay, so either the benefit is while you're doing your assignment, you can review the video, you can look at your notes. When I give this question on a test, it's done terribly. When I give it to you on assignment, it should be done fairly well because you can use the worked out example right here. So someone star example 2D from 4.5. That one's going to be important. Tell your friends. Okay, so that's the first one we did. That was a percentile type question. Okay, the next example, example 3, is the one where we actually start using the continuity correction, which is the point of this note. But this was good review. This goes through everything you need to know for the assignment. Okay, example 3 will fill in the rest. So this acts like a beautiful review lesson as well. Okay. So the last example, which has continuity corrections, it doesn't say in the example, this is a continuity correction. You have to be able to identify the language. So in this example, it says, the number of nuts in a package is normally distributed with a mean of 432.4. So I like to, as soon as I find something out, write down what it is. So if they give us a mean, 432.4. That's how many average nuts are in a package of cashews. Standard deviation of 5.8. Great. Packages with fewer than 420 nuts or more than 445 nuts will be rejected. Okay, fine. What's the probability that a package selected at random has at least 432 nuts? At least 432. So what does that mean, at least 432? They're asking us to find a probability that x is, at least is definitely greater than. Is it greater than or equal, or is it greater than on its own? At least 432. If I write greater than 432, that means basically if we're doing just tenths of a decimal, that would be 432.1 or above. This says at least 432. Is 432 okay to include? Yes. So this is talking about greater than or equal to 432. Okay, so our step here is we have to change this from greater than or equal to simply greater than. We have to make a continuity correction to get rid of this or equals to part. So it has to include 432. So do we go above by a half or below by a half? If it has to include 432 and you're going greater than that, you're going to go below. So this is actually 431.5. So this here is the step that we would consider the continuity correction. Okay, and this is the whole idea of the 4.5 note. Once you make the continuity correction, it just becomes a question like we did in 4.2 through 4.4. It's exactly the same. This is no different. This is the part of the 4.5 note. Can you get from a greater than or equal to symbol to a greater than symbol by making this small correction? Okay, so now this becomes the same type of question. When you did a greater than before, you made it 1 minus the probability was less than. Because again, the z-score table in the back of the book only gives you less than. We cannot analyze random x values. We have to convert them to z values. How do I find the z value? Well, I just do a simple z-score calculation. So z is, in our case, x is 431.5 minus 432.4 divided by 5.8. And I've already calculated this to be negative 0.16. Okay, so then it's just a matter, once you get a Z score, you simply look this up in the back of the book. Negative 0.16 is 0.4364. When I subtract that from 1, I get 56.36% of all the nut packages have at least 432 in there. Okay, just almost, just above 56%. Okay, not an overly difficult question. Okay, and again, the idea of today's lesson is just, can you do the continuity correction? The second part says, what probability that a package selected at random will fall within the acceptable quality? So it says packages with fewer than 420 nuts are rejected, and more than 445 will be rejected. So you're really looking that it's in between 420 and 445, but you need to decide, is the greater than and less than there, or is it equal to as well, or just that? So let me read what it says. Packages with fewer than 420 are rejected. If they have 420, are they allowed? Yes. So that's in the allowable range. If they have more than 445, they're rejected. So should 445 be allowed to be in the range? Yes. Okay, so then when you do the actual conversion to change it to less than symbols, you want to include 420. So you'll have to go down by 5.5. You want to include 445. So on this side, you'll have to go up by 0.5. Okay, that allows them to still include 420 and 445. If you had done it opposite, you would have excluded them, which would have changed the question. So once you make this, you change them to Z scores, and you'll do the question in the exact same way. Okay, you can look it up in the thing. I think from there, it's no problem. In a production of 50,000 packages, how many are rejected? Once you get the percentage that are rejected, you simply multiply it. So it should be no problem. I just wanted to show you how to actually do the continuity correction. Once you do that, then you just follow the note along and you can see how to fill out the rest of the solution. Okay, but today's lesson is really, can you do the continuity correction? It's a matter of really looking at the wording and seeing whether it needs to be excluded or excluded, and whether you need to go above or below by 0.5. Okay, that takes care of chapter 4 for us. By the end of this week, we'll have tidied it up. Chapter 5 is going to take us, I would say, at least 3 online weeks to get through. So we'll be looking at being in chapter 5 till we get into June. The government still hasn't made a decision as of today whether we're going back to school or not. So we'll judge June when we get there, and we'll judge the culminating then too. The culminating is very difficult to do unless you have all the computer software you need and a little bit of help with it. So we may be adjusting the expectations on the culminating in some way. But that's a June decision. Just know once we get through this, you're done 4/5 of the course content, and we'll deal with how we make up a culminating activity for June. So June will look pretty nice in this class. You'll be through the majority of the coursework, and we can focus on your other courses maybe, or just kind of boosting our mark right at the end. Okay. Oh, getting old.